Next we'll work the for-practice problem associated with 17.1. In each reaction, identify the Brønsted-Lowry acid, the Brønsted-Lowry base, the conjugate acid, and the conjugate base. So first we'll work problem A. Problem A has C5H5N, which is pyridine, reacting with water to form C5H5NH plus OH minus. Now what happened here? Notice that we have hydroxide over here on the right, so the water lost one of those hydrogens. If we redraw water as HOH, we can see that we can pull one of these hydrogens off, and so one of the hydrogens from the water was donated to the nitrogen of the pyridine. Now you don't need to be able to recognize pyridine itself if you're in my class. Just be able to recognize that the nitrogen is actually pulling a hydrogen off and actually acting as a what? Acting as a base. Okay, this is a base because it's accepting that hydrogen from the water, which is acting as a what? Acting as an acid. Okay, the water is acting as an acid because it's providing a hydrogen to that base, okay? And then what was the pyridine here has a hydrogen on it. Now it's become a conjugate acid, okay, because it could donate this hydrogen and go back the other way. This is a reversible reaction, and the hydroxide here is our conjugate base, okay? It's a conjugate base because it lost the hydrogen, so we could pick up this hydrogen and the reaction could go back the other way. So this is the base, the acid, the conjugate acid, and the conjugate base. So next we'll work part B of this problem. We have nitric acid, HNO3, plus water, H2O, yields H3O plus NO3 minus. So that's nitric acid plus water yields hydronium plus nitrate. Okay? Nitric acid plus water yields hydronium plus nitrate. Okay? And so in this case, what happened? The water didn't become hydroxide, it became H3O plus. The water became an acid, okay? And so the water is acting as a base. And what is the hydronium now? It's the conjugate acid. It's the conjugate acid of water acting as a base, okay? And so the nitric acid is our acid, the HNO3, because it donated a hydrogen here to the base water to become hydronium, and now the nitric acid itself has become the conjugate base of nitric acid, which is nitrate. So we have an acid plus a base, and the conjugate acid and conjugate base. So let's pair up these species. Here's our base and its conjugate acid. Here's our acid and its conjugate base. Here's our acid and its conjugate base. Here's our base and its conjugate acid.